Rates of change in the tangent line problem. Cadence, who are you going to call on? 3, 4, 5, 6, 7. No, Andrew doesn't have a voice. Give me another number.
3.
Crystal. By now, I'm hoping you kind of remember what rate of change means. Like, they say that a lot in calc, but in your brain, you're probably thinking a different word. Perfect, slope. Anytime you see rate of change, it just means slope. And so what we are attempting to do is make our way to being able to find slope on a curve rather than just slope of a straight line. That's what we're making our way towards. I believe pretty much all of section 1 is us making the transition. And then I can't remember what section we learned how to do it without limits anymore, which is great. So we have limits for a little bit. Okay. The two words you're going to see a lot of, actually, you're not going to see secant a lot, but you'll see it a lot this section. Secant and tangent. Tangent you're going to see all year long. This says that they were apparently taught in geometry. I don't know if they were or not. I'm sure geometry textbooks and courses are different around the places. A secant line is just a line between 2 points. In geometry, they used it as a random line inside of a circle. A tangent line in geometry is a line that just touches the circle at one spot. And so the only way you can actually touch a circle at one point is on the very outside. I don't know where I'm going to draw that. So pretend that's a nice circle. And a tangent line would touch at one location. We're going to use a tangent line in the same way. What we're going to do is a tangent line in calc is going to be the line that mimics the slope at a spot. Because it works the same as on the circle, a tangent line would basically show the slope at that location. So that's kind of what we use to show slope, is a tangent line. So you'll hear that word a lot. And it's going to feel like half your questions for quite a while. I don't know if that's good or bad, but that's what you're going to see. Oh, look at that. I could have just scrolled down and shown you what a tangent line looks like in your packet. That red line is a tangent line. And it is the tangent line right there only. So you'll see that that red line also goes through the graph over at Q. That's nothing. So the red line, the tangent line, is going to be called a tangent line because I can see the slope. It was going upwards, and then it starts curving downwards, and at that exact spot, this red line shows you the same slope as that exact location. So a tangent line would constantly shift and move depending on where your graph is. Did you guys ever do like spiral graphs? Probably the most common place to see the spirograph kits is at the Science Museum. It looks like a circle with gears, and then you put your pencil in a hole, spin it around. That's a spirograph. And when you look at your drawing when you're done, you're always kind of amazed how you got these curves, and like a lot of them were circles, but it made nice curves, and it was just kind of cool because it was made out of somewhat straight lines. That's exactly what would happen if I drew every tangent line. If I drew every tangent line on this graph, you would be able to see the curve from the tangent lines. So the secant line, the only place we're going to use this for a little bit on page 2, is you're going to find the average rate of change. I'll go back to Crystal on this one since you were a pro at it. Average rate of change means average slope, yeah, good. Average slope is the only slope you've ever done up to this point. You found slope between 2 points, and so that's actually called the average slope. You basically always found it on a straight line, which is fine. It still technically is the average slope, but on a straight line, the slope is the exact same everywhere, so it just doesn't really make sense. But if you have a curve, if I drew all the exact slopes from this point to this point, if I drew every tangent line from here to here, all of those tangent lines averaged together would be the exact same slope as what's drawn right there. So they refer to it as the average rate of change. And I'm assuming we don't need to go over much on how to find the average rate of change, probably. Or should I? Okay, I mean, I just didn't want to bore you if you know how to do it already. You remember how to find slope? Do you guys want to do that for the example right below, just to see if you remember how? Because it's not going to give you a graph or points, it's going to give you the information. See if you can find the average rate of change, that equation, that interval. This has turned into a really gross day. I know. I mean, it was cold already. It was cold enough I had to put on pants. It was in the 40s.
That's how you know it's getting.
It was in the 40s. That's my cutoff. I haven't switched to shoes yet. I don't want to do that. We'll just go socks for a little bit here. I feel like 30s is probably like 20s for sure would be a good shoes.
Out in snow.
Yeah. Oh, snow is my cutoff for jacket. I won't wear a jacket till it snows. I mean, correctly, all day long, I'm in a room that's 75 to 80 degrees. All I gotta do is make it from the door to my cars, and that's it. I see students in t-shirts and shorts all year long. You guys are nuts, because your car's much farther away. Okay, who's got this, Crystal? Somebody's gonna tell me how to find this answer. Oh, this is a really long decision. Maggie's gonna do it?
Yep.
Okay. Do you wanna come up here and do it, or do you just wanna tell me how to do it? Did you just ask which problem?
Yeah. Oh, this one. Oh, we're finding blue. Yeah.
Why did you, never mind. Okay. Oh, you're coming up, I love it.
Come up. Sure.
I love it.
Okay. Over the interval. So you would plug the numbers in to get 1 to the third minus 3. 3 times 1 over oh wait, never mind, that's
There you go.
1 minus 3.
Like, you can call on people if you want, you can do whatever, you're up here teaching.
Okay.
I was just thoroughly impressed you didn't even know what problem we're on, and you came right up to do it. 18. 18.
18?
Yeah. No, the
Oh.
answer's 18.
Okay, got it.
27 minus 9.
That makes sense. Alright, and then minus a negative 2
Yep.
over,
Nice.
Thank you.
Perfect. Okay, now, did most of you probably write it something similar to that? Okay, now is a good time to start practicing correct notation. Because the notation, the further on in the year we go, the notation is actually kind of what tells you, clues you in on how to do or how to finish a problem. What notation should we have written before this one? Because I'm guessing you guys all did the exact same thing.
F of 1.
Okay, f of 1. Yeah, b equals. But yeah, this is which equation, what number you plugged in. F of 3. Slope, you don't actually know the correct notation yet, so I'm not too worried about that part. Up here, it just used various notations. I'm not too worried about you using correct notation for slope yet. You'll learn the correct one in like section 2 or 3. But that's good. If you guys got 10, that's good. I want to say I kind of talked about this when we first started limits. So you guys sound like you're fine figuring out average rate of change. And technically, average rate of change is exactly how we figure out the instant one. We just like calculate. We pretend to move the points super close together. Okay? And I think what we did at the beginning of limits, I think we found, we estimated instant rate of change by doing this. Does that ring a bell? Okay? We're using this, and we're gonna like, get smart about it, like, use the stuff we learned. We're basically pretending that these points are moving closer and closer together. So that first point, we will just call x, f of x. So xy. The second point is a tiny bit away. There's different notation you can use to say that. I want to say in chemistry, don't you guys use delta x for like a small number? Or do you only use delta x for subtracting them? Wait, do you guys not? You're not far enough in to get delta yet? All right, never mind, I'll ask you later on then. Okay, well, you're gonna use delta x in chemistry, sir. Is anybody here already gone through chemistry? Yeah, didn't you guys use delta x?
No? Maybe like 80.
Yeah,
Delta is just change.
Enthalpy or whatever, but not delta x or y.
so what notation did you guys use for just a small amount or subtracting two things?
Oh, if you're trying to find the distance between them, yeah, it's gonna be delta x, but
Yeah.
it's like in physics.
Oh, yeah, in
Oh, is it in
not-
physics?
It's
In
physics,
physics.
yeah, I
Yeah.
just started using delta x physics.
What? Not in chemistry.
Are we using chemistry?
There's a lot of change between the atoms and, yeah, never mind. Listen, I've had way too many classes by this point. Okay, I mean, physics is fine too. Physics is basically just math. Physics is 100% the science version of math. Okay, let's pretend this point is a tiny bit away. Delta x is frequently the notation they use for saying how far away. Otherwise, I don't know why, but a lot of textbooks will just call it h. It's super annoying to me because it makes zero sense. Delta x at least makes sense, but AP frequently uses an h. So if I'm going to say that this point is real close, I'm going to say it is a distance of h away. But some textbooks will use a delta x instead of an h. Like the textbook that some of you may have checked out uses delta x. And then the height of this point is going to be f of x plus h. And I'm assuming this semi looks familiar to you because I know they had you work with this a little bit in pre-calc. If I were to find the slope between these 2 points, it would be f of x plus h minus f of x over x plus h minus x. And then on the bottom, x minus x cancels. And you have this. This is the slope between 2 points that are real close together. And say it again?
Isn't that first derivative?
No, not yet. Yeah, it's half of the first derivative.
But before you cancel, you said
X plus h minus x, yep. The reason I wanted to show this to you is because on the next page, it doesn't tell you where this comes from. It just gives you the formula. And so if you decide the second point is 0.001 away, then you would put 0.001 in place of h. And then since we're smart and we learned how to find answers where there aren't answers, we do that to it. And we say the limit of this as the bottom, as the distance between them is nothing. So we're going to find the slope between 2 points that are directly on top of each other. And then this is the calc version of slope. I know, real fun. It looks great. I want to say you guys practiced this one a little bit last year. I don't know if you did the limit version of it. Maybe. Okay. They definitely wouldn't have told you what it's for, but so this is how to find the slope when 2 points are directly on top of each other. This is on the next page. They just didn't explain where it came from. But they didn't use an X because A is supposed to be a number. Okay? If you have a highlighter, wouldn't be a terrible plan to highlight that or circle it or something. For whatever reason, they use the term difference quotient a lot. This is the difference quotient. That's the difference quotient. The limit of it is not the difference quotient, it's just the answer. What are we done today? 10:27. I was planning on stopping a little bit early so you guys can like sort of have a break and or I don't know, work on the homework or whatever. So I wasn't planning on finishing the section today. Okay, down below, shoot. Here we go. Let's do the first one together, and then I want you guys to see if you can find the other three answers. This is by far the portion that all of my calc students have trouble with. I'm not sure why, but I think it's just because it's been so long, you just don't use it enough. So we've got f of x equals 1 over 2x. Then it says find f of a. Maggie? I know you're going to choose somebody. I don't even need to guess that you're going to pick a number. I know you'll pick somebody.
Okay, Spencer.
Spencer, what's f of a? And I can go through a little bit with you if you want to.
1 over 2x.
No, awfully close though. You meant it correct. You said it wrong.
1 over 2a.
There you go. F of a just means you're going to put a in place of x. F of 2 means you put 2 in place of x. So 1 over 2a. Okay, good. Spencer, who's going to help me with f of a plus h? Sebastian. Pressure's on you.
1 over 2 times x plus h.
Close. I know, yeah.
H plus
I
h.
don't know why they're writing a, it doesn't matter, but yeah. Okay, perfect. You put a plus h in place of x. Just make sure you put parentheses like that, but if you wanted to simplify that, you could, you don't have to. Perfect. Why don't you guys see if you can do C? That's probably the hardest one. Unless you want to do all three, then go ahead and do all three. But C would probably be the hardest one up here. On C, you definitely want to simplify, by the way. You don't want to leave grouped together. Because that's how these problems are going to work, is if you simplify that down. Bless you. Okay, maybe I'll try to highlight it so it's easier to read, I don't know. I'm not even too worried about you guys doing F of A, I feel like that's pretty easy. My guess is where the difficulty ran into was remembering how to FOIL. Hopefully you didn't just square A and square H. Because A plus H squared means you have to FOIL it out, like a binomial squared. And that's, you're gonna do a lot of that, so that's why I wanted to make sure to put this example up here. Good news, you're gonna hate these first couple sections. I say good news because after we get through the work of doing that, then you learn a quick way of finding all slopes. And we get to use the quick way for the rest of the year. Okay, I don't know. Do you guys want me to go a little bit farther? Do you want me to stop here? Because we will easily be able to finish the section on Monday, no matter where we stop at this point. Okay? I'm guessing you probably also have a handful of other tests today, since it's Friday, and I kept hearing how all teachers wanted to plan them for Fridays. Or has it not been working out like that? They've just been giving them whatever day? Okay. You should be able to do roughly half the homework if you would like.